Hello everyone, this is Vardhman and welcome back. In this video, we are going to learn about merge sort, which is an application of divide and conquer. Merge sort work on recursively dividing the input array into smaller subarray and sorting those subarrays, then merging them back together to obtain the sorted array. We can say that the process of merge sort is to divide the array into two halves, sort each half, and then merge the sorted half back together. The process is repeated until the entire array is sorted. Let's understand the algorithm with the help of an example. So here we have an array A and we will sort it using merge sort. We will keep on dividing the array until we get a smaller subarray such that there is only a single element in the array, because an array with single element is always sorted. Merge sort will form a tree-like structure because every time the array is divided into two equal parts. In the start, we will have an entire array A starting at 1 and ending at index 8. This will be the very first function call. Now we will keep on dividing the array recursively until we get a small subproblem that can be solved easily. We have divided array into two parts with index 1 to 4 and 5 to 8. On the left side, we will again divide into two parts with the element 1 and 2 and 3 and 4. In the left, we will again divide the array. So here we only have two element, and on division we will get a single element. And single element is a small problem because it's already sorted. So we will get index 1 in the left and index 2 in the right. Now 3, 4 can also be divided into two parts, 3 and 4. Now coming to the right part. So 5 to 8 can be also divided into two parts, 5 and 6 and 7 and 8. Now similarly 5, 6 can be divided into two parts, 5 and 6, and 7, 8 can also be divided into two parts, 7 and 8. Now at the end you can see all the leaf nodes are single element and they are already sorted. So now we can start applying merge algorithm to their parent node to combine the array. The division part we have completed. Now we will have to conquer and combine the array to make it sorted. For the leaf node A11 and A22, they are already sorted. Now we have to sort the array at their parent node, which is A12. So we will receive two sorted array from their leaf node and we will combine those two sorted subarray to make a single sorted array. We will sort element from index 1 and 2. In the left we got 80 and on the right we got 20. So there is only one comparison needed. 20 is smaller than 80, so 20 will be the first element, then 80. Now we'll move to the parent of 1 and 2, which is 1 and 4. We have sorted left subarray with us, but in order to sort from 1 to 4, we also need right subarray. The right part we have 3, 4, and to get it sorted, we will take element from the leaf node. From the left we got 90 and from the right we got 15. So only one comparison is needed. 15 is smaller than 90, so 15 will be the first element, then 90. For A14, now we have both left and right subarray. Now we can start combining the array from 1 to 4. Here we have more elements, so you will clearly understand how much algorithm is working. Here we will compare the first element of both the array. 15 is smaller than 20, so 15 will be the first element. Now in the second we only have 90 and on the left side we have 20 and 80. So we will compare 20 and 90. 20 is smaller than 90, so 20 will be the next element. Now we have left with 80 and 90, so you only need one comparison. 80 is smaller than 90, so 80 will be the next element followed by 90. So we got our sorted subarray for the left part, which is for array from 1 to 8, we have the sorted left subarray, but we also need the right subarray to sort the entire array. On the right side, we have element from 5 to 8. To solve this, we need sorted array from both left and right side. So on the left side, we have 5 and 6, and we will sort element 5 and 6 from the leaf node. So on the left side we got 17 and on the right side we got 13. And on comparison, 13 is smaller than 17. So 13 will be the first element, then 17. Similarly for 7, 8, we will compare 150 and 3. So 3 is smaller than 150. So 3 will be the first element, then 150. Now moving to the parent, 5 to 8, we have both left side and right side subarrays. Now we can combine them. So on comparing the first element of the both, so 3 is smaller than 13. So 3 will be the first element. Now we have left with 13 and 17 on the left side and 150 on the right side. So 13 is smaller than 150. So next element will be 13. Now we can compare 17 and 150. So 17 is smaller than 150. So 17 will be the third element and the last element will be 150. Now we can combine the both left and right part from 1 to 4 and 5 to 8 to get the final sorted array from 1 to 8. Now we will compare the first element of both the subarrays. So 3 is smaller than 15. So 3 will be the first element. Next we will compare 15 and 13. So 13 is smaller than 15. So 13 will be the second element. Next we have 15 and 17. So 15 is smaller than 17. So 15 will be the third element. Next 20 and 17. So 17 is smaller than 20. So 17 will be the fourth element. Next is 20 and 150. So 20 is smaller than 150. So 20 will be the fifth element. Now we have 80 and 150. So 80 will be the sixth element. Then we will compare 90 and 150. So 90 will be the 17th element. And on the left side, we only left with 150. So 150 will be the eighth element. So finally, we got our sorted array using the merge sort algorithm. Let's look at the code of merge algo. So merge algo will be used inside merge algorithm to merge the sorted subarray. We will be using two array. The first array will be array A, which is the array that need to be sorted, and array B, which is an extra array. Merge sort algorithm is a outplace algorithm because it use extra space, which is an extra array to merge the array. We will be using three pointers I, j and k. I will be at the starting index of the first subarray. J will be the starting index of the second subarray, which will be equal to mid plus 1. And k will be at the starting index of the array B. We will compare the element at index I and j. So here 10 is smaller than 11. So 10 will be placed at index k of array B. And we will increment both the I and k. Now 20 will be compared to 11. So 11 is smaller than 20. So 11 will be placed at the kth index and we will increment k and j both. Now we will repeat similarly for the remaining element. 20 is smaller than 21. 21 is smaller than 30. 30 is smaller than 31. 31 is smaller than 40. 41 is smaller than 41. Now one subarray is finished, so we will copy the remaining element of the other subarray. Now we will copy back the element of array B into array A, and we will have a sorted array A. Let's see how much time the algorithm is taking. So we are scanning both the subarray from start to end. If the length of one subarray is x and the length of the other subarray is y, then the total time taken will be x plus y, which will be equal to n. And copying of the array will also take an amount of time. So the total time will be n plus n, which is equal to big O of n. Let's see the merge sort algorithm. We have our function merge sort. It take the array A starting index I and ending index j as input. First we will check if